What will be the bond order for CO plus? CO plus का bond order 2.5. 2.5. सी CO के लिए मैंने आपको अलग से इलेक्ट्रॉनिक कॉन्फ़िगरेशन दिया था. I gave you electronic configuration separately for CO. CO was sigma 1s2, sigma anti-bonding 1s2, sigma 2s2, pi to px equal to pi to py, sigma 2s2, sigma star 2s1. Calculate the bond order by the formula. Calculate bond order with the use of formula. Calculate bond order with the yes, Pratyusha, I gave for CO only, but CO plus means you have to remove one electron from it. CO में से एक इलेक्ट्रॉन निकालोगे तो CO plus बनेगा. That's what I have done. Pratyusha. Understood. This was CO. Remove one electron from it, it will become CO plus. How much you are getting now? According to formula, what you are getting now? कैसे यार? सुहास, half of bonding कितना है? 2, 4, 6, 8, 10. 10 is bonding. Anti-bonding कितना है? 3. So it is 3.5. Understood? So this one we have to remember because this is even more than your maximum value, which was 3. This is even greater than your maximum value, which was 3. CO plus is 3. This can also be asked, which subshell has last electron? Which subshell has last electron? So this will be our sigma star 2s. Understood? C2. What will be the bond order for C2? Sigma star anti-bonding. So CO is like an exception. Yes, CO electronic configuration is an exceptional electronic configuration because of very high electronegativity difference between the two. Because of very high electronegativity difference between two atoms. Pratyusha. Bond order for CO. Bond order for CO. But the important thing is two bonds, both are pi bonds. This is an important thing that you have to remember. Very important thing. Generally, we do not have such cases. Two bonds, both are pi bonds. This is an important thing. You have to remember it. Understood, all of you? Write down bridge bonding. Bridge bonding. When a single atom is present.
So,
Yes.
so I had a doubt in this thing.
Yes.
Uh,
Yes.
so you said now CO is an exception because of high electronegativity difference, right?
Yes.
So then even HF like is also it also has
Definitely.
an. So then they don't have an exception like thing.
We definitely have exception in case of HF also, but we are not reading that. That is not in our course, in our
Oh,
syllabus.
okay. So
Definitely,
it's
that
only
will
for
also.
CO.
Yeah, for us it is only for CO.
Okay, sir.
Yeah.
Thank you.
Bridge bonding, when a single atom is present between two central atoms, such bond is called bridge bond, and corresponding atom is bridge atom. Understood? For example, BH3, a trivalent species get dimerises to give B2H6. So this bond is banana bond. This is bridge atom, bridge atom. Any doubt in this picture? Any doubt in this picture? Do you think CH3 will also behave in a similar manner? Do you think CH3 will also behave in the similar manner? Pratyusha, I'm asking about CH3. Ronald is saying no. CH3 will also behave in a similar manner. Kimaya, Komal, no. Why? Because CH3 has an extra electron. An extra electron. कार्बन के पास 4 इलेक्ट्रॉन्स होते हैं. So it will form simply an ethane. No bridge bond. No bridge bond. डायोरेंट के अंदर there is no extra electron. No extra electron in boron. No extra electron in boron. Okay, Komal. No extra electron in boron. There is only a vacant orbital. There is only a vacant orbital. Okay. So boron does not have electron. Boron does not have electron. Hydrogen has 1 electron. Boron does not have electron. Hydrogen has 1 electron. So I am drawing the boron electrons. Boron electron, boron electron, boron electron. Okay. So this electron, this bond, boron electron, hydrogen electron. Boron electron, hydrogen electron. This will be hydrogen electron, hydrogen electron, hydrogen electron. So boron, all the 3 electrons have been done. Boron electron has been done. So this will be a 3 center 2 electron bond. 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 This is also a 3 center 2 electron bond. 3 center 2 electron bond. Any doubt in this? It is a 3 center 2 electron bond. There are 3 center 2 electron bond. All of you are getting these 3 centers? 3 center. Pratyusha, what you didn't understand? Please speak up.
So I didn't understand the boron thing. I mean, there are 3 hydrogens attached over there, right?
How
For
many
first 3.
electrons? How many electrons boron had? How many electrons boron had?
Valence electrons.
Yes.
It's 2s2 2p1. So 3.
Yes, Deepika, it's correct. So, Pratyusha, these are boron 3 electrons. Okay.
Yeah.
Now, boron does not left with any electron in this case.
So wait, yeah, there's no electron, as in
That,
it's not left.
but Yeah, that means there is no bond between hydrogen and boron.
Yeah, there's no bond.
But here we have boron one electron and hydrogen one electron.
Yeah.
That means here there should not be a bond,
Yeah, there's no
but
this.
you can see the bond
Yeah. Why, even if
because
there's no bond, then why do they draw a line over there?
this bond is moving like this. Sometimes here, sometimes here, sometimes here, sometimes here. It is a partial
Oh,
bond between the two.
it's like a canonical structure, something.
Yes, 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 exactly like that. If you can
Okay.
refer that thing, so it is completely
Okay.
like that. It is not the actual bond; it is a
Hmm.
partial bond kind of. But that much
Uh-huh.
information has not been given.
Okay.
Okay,
And
yeah.
then what happens to the
So
other hydrogen, the down one, the that
similarly,
same it works
this
like both
yeah,
ways.
exactly. It will same work like both the ways. So this bond is partially present that side, partially present this side. So basically, two boron atoms and one hydrogen atoms are bonded through two electrons only.
Wait, two electrons?
These two
Which one?
electrons.
Oh,
I'll take another color. Just wait.
yeah.
These two electrons. These two electrons are holding three atoms.
Oh, wait, how is it
Th-
three?
three atoms.
Um,
Yes.
no, I didn't understand that part.
See these two electrons. This red one and blue one.
Hmm.
This one.
Yeah.
This is sometimes present here, sometimes present here, sometimes present here, sometimes present here, right?
Oh, okay. Yeah, yeah.
So the bond is present between both the sides.
Yeah.
So it is holding all the three atoms. Yes or no?
Yeah. Okay.
So that is why it is called three center two electron bond.
Okay. Now because it's shifting on both the sides and it also
Yes.
includes three atoms. That's why it's called.
Yes.
Okay. Got it.
And such we have both the sides. ऊपर भी और
Okay.
नीचे भी.
Hmm.
Understood?
Yeah,
So
sir.
that is your three center two electron bonds. We have such two. We have two three center two electron bonds.
Okay.
Okay.
Got it.
Do you think that these bonds will be weaker than these two center two electron bonds?
Which two centered? The
These bonds,
okay.
these are simple
Uh,
bonds.
yeah.
Simple bonds, right? The bonds we
Yeah.
know.
Hmm.
Do you think these bonds will be weaker than the common bonds?
Mm, no.
No. Why? Komal is saying
Because
yes. Yes. So, in case of three center two electron bonds, they are partial bonds. Yes or no?
yeah. Okay. So they, I mean, they go on changing like.
Yes. So there is a partial bond.
Okay. Oh,
If they
those
are
are
partial,
fixed.
yeah, those are fixed. So we
Okay.
can say three center two electron bonds will be partial bonds, will be
Hmm.
weaker bonds, will be longer bonds than that of the common bonds.
Okay. Yeah.
Understood? Yeah.
Yes. Thank you.
So three center two electron bond will be weaker than two center two electron bond and longer than two center two electron bond. Okay. Any doubt to anyone in this? Any doubt to anyone in this? All of you understood this? We have, should I say we have four two center two electron bond? Should we say this? We have four two center two electron bond and two three center two electron bond. All of you getting this? Copy each and everything. I'll make it again. What will be the hybridization? Hybridization of boron. I gave you this in BCl3. Sorry, BCl2. Hybridization of boron. Hybridization of boron. Kimaya, Komal, 4 bonds. 4 bonds. Deepika, 4 bonds. Deepika, Kimaya, Komal, 4 bonds. I told you that in BCl2 also. 4 bonds, sp3 hybridized. So, but is it in the 4 bond partial bond? Yes, it is a partial bond, but at least it is a bond. We have to consider that also because it is a sigma bond. We cannot say the bond is not there. Suhas, I will go to AlCl3. Please wait. Next, I'll take AlCl3 only, Suhas. Just wait. Okay. All these atoms are present in one plane. All these atoms are present in one plane. All these atoms are present in one plane. Horizontal plane. Horizontal plane. How many atoms in horizontal plane? How many atoms in horizontal plane? How many atoms in horizontal plane? Six atoms. Horizontal plane, 6 atoms. HA and HB are perpendicular to the horizontal plane. How many atoms in vertical plane? How many atoms in vertical plane? How many atoms in vertical plane? यार 2 होता तो मैं पूछता ही नहीं आपसे. 2 पूछने का मतलब नहीं है. How many atoms in vertical plane? This will be the vertical plane. This will be the vertical plane. थोड़ा सोचो. Directly answer. This will be the vertical plane. If you take a piece of paper, put one atom above it, one atom below it, you will understand this. This is your vertical plane. Okay. ठीक है, this is your vertical plane. This is your vertical plane. Yes, it has to lie. Pratyusha. See, if we have this paper, okay, and we have something here. If you put one atom just above it and one atom just below it, then this will be your vertical plane. If this is your vertical plane, then definitely this will also come in that vertical plane. और horizontal में तो आएगा ही. You can see it. This is your horizontal plane. So this atom has to come in that. So it is present in both the planes. थोड़ा सा 3D फिगर है, क्लास में होते तो उसको डिस्कस कर सकते थे. अभी you can remember it. Understood? Vertical plane, horizontal plane. All of you understood B2 at 6? If we take AlCl3, if it get dimerized, it will give Al2Cl6. Suhas, that's what you were saying. है ना? Suhas. So everything will remain same. So do you think there will be some difference between B2 at 6 and Al2Cl6? कोई difference होगा B2 at 6 and Al2Cl6 में? Do you think there will be some difference between B2 at 6 and Al2Cl6? No. Bridge atom, it looks same. यार look के ऊपर नहीं, हम chemistry में बात कर रहे हैं. Bridge atoms have lone pairs here. Yes or no? Bridge atom. Please mute your mic. Please mute your mic. Bridge atoms have lone pair here, right? So this is aluminium electron, aluminium electron, aluminium electron. And let this be aluminium electron, aluminium electron, aluminium electron. This will be chlorine electron, chlorine electron, chlorine electron, chlorine electron, chlorine and chlorine. But as chlorine has lone pair, it can form a coordinate bond. Yes or no? As chlorine has lone pair, it can form a coordinate bond. Yes or no? Yes or no? So we do have a difference. We do have a difference. Here we have three center, four electron bonds. Here we have two, three center, four electron bonds. Here we have two, three center, four electron bonds. And four, two center, two electron bond. Pratyusha, do we have a partial bond here? Do we have a partial bond here? No. No partial bond. No partial bond. Instead, we have two coordinate bonds. Two coordinate bonds. Understood? Why we cannot have a coordinate bond in B2H6? Why we cannot have a coordinate bond in B2H6? B2H6 के अंदर coordinate bond क्यों नहीं हो सकता? Why we do not have a coordinate bond in B2H6? Less electron नहीं, no lone pair. Hydrogen does not have lone pair. B2H6 does not have coordinate bond, but banana bond because because hydrogen does not have lone pair. Lone pair. Understood? Pooja, Manjita, Kimaya, Asmita, Ronald, understood? All of you? Kimaya done? Okay. Hybridization. Hybridization. sp3, definitely. Horizontal plane 6, vertical plane 4. Understood? Any doubt in this? Any problem to anyone in this? Al2Cl6 B2H6. Back bonding. Back bonding. Transfer of electrons from an electron rich atom to an electron deficient atom having vacant orbital present adjacent to it. Adjacent to it. Present adjacent to it. Copy it first. Back bonding leads to form a pi bond always. ठीक है, देख लेते हैं पहले क्या होता है. For example, if we have BF3, what is the hybridization of boron? What is the hybridization of boron? कैसे sp3 यार रोनल sp3 कैसे हुई बताओ थोड़ा. शिवांगी भी sp3 बोल रही है. शिवांगी, Ronald, how it is sp3? Three bonds are there. So definitely there will be a vacant orbital in boron. एक p vacant हो जाएगा. One p will be vacant. One p will be vacant. Vacant orbital. So these electrons get transferred here. Transfer of lone pair from fluorine to boron gives back bond. Back pi bond. Understood? Any doubt to anyone in this? So, but if they are stable, why they have to share more electrons? No, boron has a vacant orbital and fluorine has extra pair of electron. More the number of bonds you can form, more stability it will gain. जितने ज्यादा बॉन्ड बनेंगे उतना ज्यादा स्टेबल हो जाएगा वो. Whenever there is a chance of back bonding, it will happen all the time. Okay, they are not stable. They are Lewis acids. They have a shortage of pair of electron. If you have done equilibrium chapter, तो उनके पास shortage of pair of electron है. They always need a pair of electron. That's why they are gaining it. Understood?
So,
Yes.
so
Yes.
for that BF3 thing, uh, firstly, boron it has total 6 electrons, right? From
Yes.
sharing and all that. So,
Yes.
and now those lone pair electron go into the vacant orbitals of boron. So
Yes.
then, won't it be extra electrons in boron?
How many total electrons do we want for a molecule to be stable?
8 to complete
Eight.
the
And we are,
octet.
and that's what we are doing. We are making it eight. It was six. We have given two electrons. It becomes eight.
But then the other fluorine is also there, right? That won't form
Yeah,
a
but
back bond.
once it can form, but only one at a time. If you want, I can make that one. I'll remove this. If you want, I will make other one. I'll remove this. For only one back bond can be formed. Because once the back bond is formed, boron has got 8 electrons. Once that 8 electron has been formed, then no more back bonding will occur.
Okay, so it's only like only one from both of them goes. Only one this thing,
One
one
from all
fluorine
the
atom.
three. Yeah, from the three, only one fluorine will form.
Okay.
Yeah.
Yes, got it. Thank you.
Now, if you ask me that which one
Uh,
will do, I can say any one of them can. Any one of them can do
any
that. Yeah.
fluorine. Yeah.
Anyone. Yeah.
Yeah.
Understood?
Yes, sir.
Okay. Which overlapping do we have, Pratyusha here? Which
As
overlapping
in,
do we have? Like
like high
which orbitals are involved in this back bonding?
p orbitals.
Which specifically to orbitals? Which
As in,
specifically? This is 2p electrons of fluorine, and this is
yeah.
also 2p of boron. So it is
Okay, you meant the
2p
actual
overlapping.
orbitals. Okay,
Yeah,
like that. Yeah.
2p overlapping we have here. Very good, Suhas. Understood, all of you? Extent of back bonding will depend upon the energy difference between orbitals involved in back bonding. 2p is better than 2p 3p is better than 2p 4p. Understood? Any problem to anyone in this extent of overlapping? Sorry, extent of back bonding? Any problem to anyone in extent of back bonding? In which of the following Bx bond order is maximum. More energy, so it is more stable, or is it opposite? There should not be the energy gap between the two orbitals, Pratyusha. Energy gap ज्यादा नहीं होना चाहिए. 2p will be better than 2p 3p. Electrons can easily move from 2p to 2p, but cannot move from 2p to 3p or 3p to 2p. Energy gap should be very less. Yes. चलो बताओ ये क्वेश्चन. In which of the following Bx bond order is maximum? Jared, what will be the answer for this? Rebecca, Manjita, done? Bf3. All of them have bond order greater than 1 due to back bonding. But all of them have bond order greater than 1 due to back bonding. But 2p overlapping is best among all. Hence, BF3 has maximum bond order. Very good, Deepika. Suhas, you understood? Okay. Which among the following has maximum Lewis acidic character? Which among the following is maximum acidic? Which among the following is maximum acidic? प्रत्युषा, which acid we are talking about here? किस तरह के एसिड के बारे में बात कर रहे हैं? पूजा, वेरी नाइस. Pratyusha, what type of acid we are talking about here? Lewis acid. What do we mean by Lewis acid? What do we mean by Lewis acid? Lewis acid means shortage of pair of electron. All the given molecules are Lewis acids. That is, they have sextet of electron, shortage of pair of electron, shortage of pair of electrons, but back bonding back bonding decreases Lewis acidity by donating electrons to central atom to central atom. So back bonding is inversely proportional to Lewis acidity. Understood, Pratyusha? Very
So,
good, Tanvi.
so,
Yes.
uh, so that means like only for BF3 only. These electrons, when they go in the vacant orbitals, that means it
Yeah.
completes the octet. So that's why it's called, as in the Lewis acidity decreases or something.
Yes, it is the same thing. Earlier it
Yeah.
had 6 electrons, but now as the electrons has been transferred from fluorine to boron, so its deficient nature has been decreased. So its Lewis acidity has also been decreased.
So the shortage of electron decreases. That's why
Yes,
the this inversely proportional.
yes. But
Okay.
I will not say that it is not deficient now. I will say it is least deficient now.
Okay.
Okay, this should be
Yeah.
very much clear. BF3 is a Lewis acid, but is least among all the BCl3, BBr3, Bi3 because it has maximum back bonding.
Okay, sir.
Understood?
Yeah. Yes, sir.
All of you understood this? Extent of back bonding decreases with increase in electronegativity. Electronegativity across the period. Okay, this will come in organic also. So please remember this. Back bonding will come in organic also. So please remember this. Across the period, it will depend upon electronegativity. Across the period, it will depend upon electronegativity. Down the group, it will depend upon energy difference. Okay, first tell me this. Which one is maximum stable? Which one is maximum stable? Which one is maximum stable? CH3 plus is maximum stable. कैसे? Now, Shane. Pooja, how it is CH3 plus? No back bonding. Back bonding. Back bonding. Back bonding between 2p 2p. Back bonding between 2p 3p. So this will be maximum stable. Very good, Komal. Understood, Pooja. Thakkar. Yeah. Pooja. Now, Shane. Now, as you have completed your 11th and 12th class, we can put such questions also. Tertiary means it has to be attached to 3 carbon atoms. Pratyusha, is it attached to 3 carbon atoms? टर्शियरी का मतलब वो 3 कार्बन से अटैच हो. यहाँ तो ये हाइड्रोजन से अटैच है. चलो. Which one is more stable and why? If there was 3C, then also it won't be stable. Back bonding will always win. बैक आप जो बोल रहे हो वो हाइपर कॉन्जुगेशन है प्रत्युषा, और जो मैं बोल रहा हूं वो बैक बॉन्डिंग है. बैक बॉन्डिंग विल बी मैक्सिमम पावरफुल. हम ऑर्गेनिक में इसको डिस्कस करेंगे. बैक बॉन्डिंग मैक्सिमम पावरफुल होगी. हाइपर कॉन्जुगेशन इज नॉट इवन ग्रेटर देन रेजोनेंस. बैक बॉन्डिंग इज इवन ग्रेटर देन रेजोनेंस. टेल मी दिस, which one is more stable? Pooja. Pooja, Deepika did the statement. Why Suhas? Why Pooja? Reason क्या है? Nawashin. Can we have back bonding? Yes. Can we have back bonding? Yes. Interaction 2p 2p. Interaction 2p 2p. कोई difference नहीं है. Now we want less electronegative. We want less electronegative. We want less electronegative. Cause exchange of back bonding decreases with increase in electronegativity. Very good. Himaya. Suhas. Suhas, then why you said B? We want less electronegative. सुहास फिर आपने बी आंसर क्यों किया यार? We want less electronegative. Yes, sir. The answer is A. All of you understood? Pratyusha, Manjita. What about other students? वही 5-7 बच्चे बोलते रहते हैं, बाकी सब क्या कर रहे हैं यार? But like that for previous question, fluorine was. Pratyusha, I said across the period we check electronegativity. Along the group we check size. Sorry, energy difference. मैंने बोला ये. ऊपर से नीचे जाते हुए हम एनर्जी गैप चेक करेंगे. Am I audible? All of you, please add that point if you have not done. Across the period, check electronegativity. Across the period, check electronegativity. Down the group, check the energy difference between the two. सुहास, आप भी पूछ सकते हो यार, किसी का वेट मत करो. If she'll not ask, then you won't get your out clear. आपको अपना सिलेक्शन करवाना है. If you have any doubt, you should ask. किसी के भरोसे मत बैठो. ओके सुहास, चलिए ठीक है, समझ में आ गए? ऑल ऑफ यू अंडरस्टूड दिस? ठीक है ठीक है ठीक है, समझ. Trimethyl trimethyl amine is more basic than triacylyl amine. Why? Trimethylamine is more basic than triacylamine. Why? Trimethylamine is this. Triacylamine is this. Yes, Komal. The only difference you can see is I have replaced carbon by silicon. मैंने कार्बन को सिलिकॉन से रिप्लेस कर दिया है. Please mute your mic. Ria, Rimberly, please mute your mic. only real. Why is it so कि माया क्या रीजन है? तुम क्या आंसर कर रहे हो यार? पूछा उसमें वाई, उसमें तो लिखा ही हुआ है कि मिथाइलामीन इज मोर बेसिक. इट इज ऑलरेडी गिवन फर्स्ट वन इज मोर बेसिक. बताना है क्यों. Which energy difference you are talking about? Navashen, do you want to say in both cases we have back bonding? Navashen, are you saying in both cases we have back bonding but we have an energy difference? Please reply fast. Komal. See, do you think carbon can have back bonding? कार्बन बैक बॉन्डिंग कर सकता है क्या यहाँ पर? पूजा, कैन वी हैव बैक बॉन्डिंग इन केस ऑफ कार्बन? हाउ मेनी मैक्सिमम बॉन्ड कार्बन कैन फॉर्म? पूजा, how many maximum bond carbon can form? 4. And it has already formed 4 bonds. Yes or no? Navashen, वो मैक्सिमम 4 बॉन्ड बना सकता है. 4 पहले ही बना लिए हैं. Navashen, so no back bonding. No back bonding. Do you think silicon can form back bond? Silicon बना सकता है back bond? Can silicon have back bond? Can silicon have back bond? Why, Kimaya? Very good, Navashen. But silicon is a member of third period, so can accept pair of electron from nitrogen. Any doubt in case of silylamine, Komal Joshi? Understood this? As in case of B, lone pair of nitrogen are involved in back bonding, so not available to show their basic character. बेसिक कैरेक्टर का मतलब क्या होता है? डोनेशन ऑफ पेयर ऑफ इलेक्ट्रॉन. बेसिक कैरेक्टर का मतलब होता है डोनेशन ऑफ पेयर ऑफ इलेक्ट्रॉन. सो इलेक्ट्रॉन्स कैन नॉट बी डोनेटेड. नहीं किया जा सकता. इलेक्ट्रॉन्स कैन नॉट बी डोनेटेड. Why? Because they have been involved in back bonding. क्योंकि वो back bonding में involved. Understood? Understood, all of you? Understood, all of you? In the above question, A is pyramidal, B is planar. Why? Hello. In class, done. A is pyramidal, B is planar. Why? I told you all the shapes, geometry, सब कुछ बताया था मैंने आपको. Because in case of A, x equal to 3. A has lone pair. Very good, Jared. But what is she saying? Kimaya, how can you say A has x equal to 3? A has lone pair. A has lone pair. 3 bond pair, 1 lone pair. इसलिए pyramidal. B has not, do not have lone pair. Why? Due to back bonding. तो इसीलिए there will be 3 bonds, 3 bond pairs, 3 sigma bonds. So it will be sp2 planar. Okay, Kimaya. मिस्टेक मत करो यार, आराम से बताओ, रुक के बताओ. Done. All of you understood? Back bonding, bridge bonding. Any problem to anyone in this? If you do more practice, you will get better. ठीक है. अब बढ़ते हैं intermolecular forces. This will lead us to the next chapter. Intermolecular forces. What do we mean by intermolecular forces? And why do we need them? क्या मतलब होता है intermolecular forces का? Force of attraction between different molecules help to hold atoms in place. Atoms क्यों बोलेंगे यार? When we are saying intermolecular, we'll talk about molecular force. Atoms का कोई सीन नहीं है. To keep two molecules together. Can I say to determine the state of the substance? Can I say to determine the state of the substance? Can we say to determine the state of the substance? It is responsible for the physical state of substance. It is responsible for the physical state of substance. Matlab, if we have weak intermolecular forces, it will be gas. If we have strong intermolecular forces, it will be liquid. IR means IR कहाँ लिखा है मैंने? Force of attraction between different molecules. It is responsible for the physical state of substance. I Komal, where I have written IR. So you want to ask something? Intermolecular forces are the force of attraction present between the molecules. It is responsible for the physical state of substance. ठीक है. What are interatomic forces? Interatomic forces क्या है? Interatomic forces जैसे फॉर एन एग्जांपल दीपिका, ऑब्वियसली वो तो फोर्सेस बिटवीन द डिफरेंट एटम्स हो जाएगा. प्रत्युषा एग्जांपल like covalent bond. Metallic bond. Let's say ionic bond, though it is between ions, but let's keep them together. So we are not talking about these forces. It should be very much clear. We are not talking about these forces. हम इन forces के बीच में बात नहीं कर रहे हैं. We are not talking about the interatomic forces. We are talking about intermolecular forces. Okay, Pooja, Deepika, done Komal. ठीक है. So if I have methane, so what type of force is this? ये कैसी force है? What type of force is this? This is interatomic force. Interatomic force. But what we are talking about is, what we want to read is, if we have 1000 molecules of methane, हमारे पास 1000 molecules है methane, they are separate from each other. All of them are separate from each other. But then also, what force do they have between them? What interaction do they have between them? We are discussing that particular force. We are going to read about this. हम इसके बारे में बात करेंगे. This is understood. Understood. Should I say intermolecular force will always be weaker than interatomic force? Should I say intermolecular force will always be weaker than atomic force? What about others? Can we say intermolecular force will always be the weaker force and will always be lesser than interatomic force? Are always the weak forces? Are always the weak forces and lesser than interatomic force. Intermolecular forces are always the weaker forces. So then what is intramolecular force? Intramolecular force is the force of attraction present between different groups in the same molecule. All of you understood till here? Pratish, I'll come to that. Just wait. All of you understood this? Intermolecular forces are weak forces and always lesser than interatomic force. देखो, I'll take one example which is there in our course as well. Pratyusha. ठीक है, as we have done 11th and 12th both classes, you can easily understand it. This is a separate molecule, Pratyusha. This is also a separate molecule. But overall, it is one molecule, orthonitrophenol. Right, Pratyusha? This is molecule A. This is molecule B, or you can say group A, group B. But overall, it is one molecule. ये पूरा एक molecule है. इसका नाम है O nitrophenol. So we have intermolecular force within the molecule. दो different groups के बीच में within the molecule. This is called intramolecular force. Intramolecular. Understood, Pratyusha? But if I take water, if I take water, if I take water, water, so intra is same as atomic. No, atomic is used to form molecule. Atomic force होगी atoms के बीच में. This is between two molecules. This is intermolecular force. Intermolecular force. Intermolecular force. This is between different molecules. We have different molecules and they are attracted towards each other. They are attracted towards each other. ठीक है, ये आपकी intermolecular force. If it is between different molecules, it will be intermolecular. If it is between in the same molecule, it will be intramolecular. But if it is between the atoms, it will be interatomic force. Okay, Pratyusha. नाइट्रोजन और ऑक्सीजन के बीच में देयर इज इंटर एटॉमिक फोर्स. इंटर एटॉमिक फोर्स. इंटर एटॉमिक फोर्स. कोवेलेंट बॉन्ड. बट हाइड्रोजन और ऑक्सीजन के बीच में दिस इज इंट्रामोलिकुलर. इंट्रामोलिकुलर. Between different molecule, intermolecular. Okay, प्रत्युषा. ठीक है, तो अभी इतना करते हैं. Rest will do in the next class.
So same in the case will be for O and H down in water, right?
Definitely, definitely.
Okay.
It is, but that is not intra. It is at interatomic, right?
So that's what interatomic between O and H of the same molecule.
Yes, 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 yes. O and H of water is interatomic force, right? There should not be any confusion between intra and interatomic force. Intramolecular weak force होगी, dash से show करेंगे. We will show it by a dash line. We will show it like this, like this. Interatomic force will be a covalent bond shown by a solid line. Yes, Pratyusha. Second chapter will come for the test. Okay, Pooja. So that is it for today.